Hi, CS260. This is Professor Jensen, and today we're going to be talking about the web framework React. And we're going to give you a simple introduction, and we're going to talk about how you can build components and how the React JSX, which is their JavaScript HTML representation, gets turned into something that the browser can actually utilize using the Babel transpiler. So to jump right in, let's go ahead and get our overview of where we are in our application. So we previously used JavaScript, HTML, and CSS to build simple applications, and we, over the internet, used HTTP to be able to talk to a backend service, and that backend service then talk to databases and other things like that to return over our service endpoints information there. Now we want to actually make use of modern web frameworks to be able to make that HTML, CSS, and JavaScript much easier and much more reactive to what the user is doing without having to do a whole bunch of DOM manipulation ourselves. And actually modernize our code and make use of things like ES modules to modularize what our code representation is. So let's jump right in. This is what web frameworks generally provide. They provide simple common patterns that have been developed over decades to make it so you don't have to recreate the wheel every time. They provide common components so that there's basic web application components that you can just bring right in. Similar to what you were seeing with like Bootstrap and CSS, we now have components for actual functionality that you can bring in and display within your application or use within your application. They also improve performance because they make sure they take the best techniques for making your application as fast as possible, so you don't have to worry so much about that in every line of code that you actually write. And they also increase device coverage. Because they're using common patterns, they know the particularities of each individual device that you could actually be executing on, whether that's an Android app, a Samsung Android app, an iPhone app, desktop application, or even a TV. It knows how to deal with each one of those things and makes it much easier so that you don't have to worry about the peculiarities of each device you might want to run on. So there's a lot of frameworks out there for doing web applications. React by far is the most popular one right now. You can see over time here, according to the usage graph, that it's 82% of web application developers are using React. 49% are using Angular, 46% are using Vue, and then it kind of goes down from there. I will note that one of the rising stars there is Svelte. They've been getting a lot of traction in the last few years, and they have actually got a pretty good model there, which overcomes a lot of the problems that a more legacy application framework like React or Angular have stumbled into just because they're trying to maintain old methods of processing. So if you're looking for a new web application framework, I might suggest Svelte as one to look at. But for this class, because it's the one that's used most often, we're going to be using React to demonstrate how to use a web application framework. So React was created by a guy named Jordan Walk. He was working at Facebook, and he was trying to make it easier for them to be able to develop web applications much, much faster. And initially deployed this on Instagram, and then they've deployed it in multiple different applications within Facebook or Meta, as they're known today. But then they open sourced it and made it so that anybody could use the React framework to do it. And that's what instigated the wide acceptance of the framework, that they had a big player behind it, maintaining the code, making sure it worked right, and also making it so that there was a high quality application that people could use and share and also contribute to. So one of my favorite quotes from Jordan is this one here. It says, "The best drug is getting little things done that have been weighing on you, instant high." And I find this is very true. You've got your list of tasks that you got to do, and you want to be, as an application developer, you want to have a high velocity of how you deliver things. You want to be a valuable team member to contributing towards whatever your company's goal is for producing it. And as you build up those goals kind of going on, they start to weigh on you, like, oh, I've got these different tasks and deliverables that the team is waiting on. But as soon as you're able to like check that off, then it's like the best drug out there. You can feel it. It's like, I've accomplished something. It's something that's meaningful, and it's something that helps other people out. And hopefully you're feeling that with your startup deliverables. As you check off each one of those deliverables that you have, you should feel really good about that. You should be like, I have accomplished something really cool. Now, it may not be the coolest thing out there by what professional web developers may say, but it's at a cool level for what your skill set is, and you should feel super proud about that and go and celebrate the fact that you've done something, that you've checked off one deliverable, and that will help you get excited about delivering the next one. Okay, core concept of React is this idea of what's called the JSX. And what JSX is it combines JavaScript and HTML basically into one representation. Now, when Håkon Lie and Tim Berners-Lee created the initial JavaScript, or the initial HTML and CSS, and then Brandon Ikes came out and created JavaScript. They kept those intentionally separate from each other. They were trying to separate their concerns. But what we actually found is that they're really just separating the logic of one thing into multiple files, which is not such a great thing to do. It makes it difficult to maintain it. It makes it difficult to know how they relate to each other. And so separation of files is not the same thing as separation of concerns. So what you really want is a component that represents one piece of functionality, and everything you need to do to actually create and render that component is represented in one place. And so that's why keys, things, and almost all of the major web application frameworks have this idea of creating a component, and then you put your JavaScript, your HTML, and your CSS all within that one thing. Now, JSX doesn't actually directly represent CSS. It only really combines the JavaScript and the HTML, but you'll see how powerful that actually is as we go through these examples. So since JSX is introduced, that's not something that the browser actually knows what to look like, what to do with. And you can see an example here at the top of the screen of a very simple JSX program or object. So it's got some JavaScript, sets a constant equal to I. It then allocates a block of HTML that then injects that JavaScript directly into the HTML, all within one representation. That's a very basic JSX object there. So you can't just give this to a browser. It doesn't know how to handle that. It'll look at that and just basically ignore it, or give you something that looks like garbage as it tries to do its best with what you've given it. So you've got to somehow convert that JavaScript HTML combination of JSX into JavaScript or HTML that the browser can actually render. And the tool that actually does that commonly is a tool called Babel. Meaning that I can take different languages and I can combine them and come up with the language that everybody can actually speak. And so we can take that thing, run it through the tool called Babel, and it will transpile or translate and compile that object into just a single JavaScript representation. And that JavaScript representation knows how to interact with the DOM, and so you can actually have a function like createElement that takes the element tag as the first parameter, whatever attributes that element needs as the second parameter, and then the child as the third parameter. And then if there's JavaScript that needs to be related to that, you can inject those in there as additional parameters on the create element. So it takes that HTML representation, it takes the JavaScript representation, it combines them together and provides them into something that then this function right here, create element, can then use to inject HTML into the DOM. And that's basically what JSX, the magic behind JSX and how it actually works. So if we go look at that simple example here, we can actually go out to Babel, to their website, and try out and see how this actually works. So if I come back here and we escape out of this and grab this code right here, and we paste this in. So on the left side is your JSX, and on the right side is going to be the generated JavaScript that's actually coming out of it. So if we paste that in here, and we can make this a little bit bigger so you can see what's going on. And get rid of this. You can see that it takes this thing and converts it just like I was showing in the slides to this representation. But if I make it a little bit more complex, so it's creating an ordered list, and that ordered list has one attribute called big, and that's right there, a class attribute, and then it's got two children. So it's got this create element, which is a list item, which just has an item in it, and then it's got a second one, create element, to create the second item in the list. And you can kind of take the leap at this point because you've messed with the DOM so much that you can see how it's actually producing the JavaScript that will then take those parameters to the createElement function and inject that into a DOM representation. And you can use this tool to actually experiment and see however you want. So if I went down here and I put a new class, or let's actually put an ID on it, in this case here, and I'll call this the cow ID. You can see that it had an error there, right? I couldn't compile that at that point, but once I finished the code looking good, then it was able to actually inject into the, here's your tag name for the element, and then you can see there's the attribute that I just added for that ID, and then the text body of its child in that case, and then just the parameters that it's going to use to actually display information within that. So that's the value of I in there. And you can play that game all day long to kind of get familiar with how Babel actually works. So if we go and look at CodePen, we need to tell CodePen that it needs to use Babel in order to transpile your code if you're going to use JavaScript within it. So if we go out to CodePen and use this simple example here, you can see that I've got this root element with an ID of, in my HTML. And that's all that's in there. There's nothing else in here. And you can see it says loading, but the actual rendered version doesn't say loading, which means that our JavaScript has already ran and injected the resulting JSX into the child of that div element. And that works by importing the React libraries, which this is being done by just bringing it down from a content delivery network, a CDN, from someone who's hosting that on the internet, and bringing in the React functionality and the ability for React to manipulate the DOM. And then we're calling the React DOM function to render this JSX, which is at this point looks just like HTML, but it's not quoted, it's not a string, and it's in a JavaScript file, so it's actually JSX, as the element that needs to be put into, and then the second parameter here is the selector of where you're going to stick that into, the resulting JSX. And so if we look at that, it's selecting the root element, so it's coming up here, finding that ID in there, and then it's rendering, because it's actually running Babel, to compute this in from the JSX representation to that, that JavaScript representation that I just showed you in the Babel tool, and then injecting it in there. So this right here becomes what gets put into the HTML. And I can show you that we can make this more complex by actually introducing JavaScript in here. So if I do a const of, txt is equal to cow, then I can come down here to my JSX and I can inject that in there by putting a curly brace on either side and putting in my variable, which is txx and txt, and that will actually get rendered, and you can see that it's actually putting there. Oh, and I put a little extra apostrophe on there so I can pull that out, and CodePen will automatically regenerate the JSX by using the Babel compiler to actually convert that over to JavaScript, and then it renders. To make your CodePens actually work with JavaScript, all you have to do is click on that configuration for it and then specify, normally it's none, meaning you have no JavaScript processor. You can see that it changed there to actually being a Babel processor, and then it will actually run and convert your JSX over. So if you're using that within CodePen, just make sure you set that configuration there to use the Babel processor, and then you'll actually be able to see the results of your JSX really simply within the nice sandbox code environment of CodePen. So that's Babel in CodePen. So let's talk about the next important part of what React actually provides. We just talked about the ability to write JavaScript and HTML code together within that, and that's used in the JSX representation. But we want to talk next about components, because that's the basic module of representation within the React environment. So a component, if you just look at it logically, is taking some piece of your application and pulling out and making a single object or component representation of that functionality. So in Simon, and this is actually how it actually works for the most part, is you could have 3 different components on your main page. You can have a header component, which displays the navigation functionality. You can have a footer component there, and you can also have a main component. And that main component can have the Simon game represented there, and you could use a component for each one of the buttons. So that functionality isn't being written multiple times. You just create one component, and then you put parameters to it that tell what color it is and what orientation it is. And then you can make every button within the application, if you want to, actually a different component. So the reset button might be a different component. And then you just got this hierarchy of components, starting at the top with your application, and that application contains a header, a main, and a footer component, and then that main component contains a game component, and that game component contains button components, and the game component also contains the actual push buttons that you're using to highlight the application within there. So you create this tree of components all representing the functionality of your application. So to actually create a component within React, I've got 3 different simple examples. So The first one that I want to show you is the simple representation of a component. And this is basically what I just showed you. So you've got just straight JSX in the render function, which is associating that JSX. And this right here is literally a component. It just doesn't have any JavaScript associated with it. So it's just pure like HTML being injected into the root component. So that one's kind of boring, and we've already manipulated that to make it more interesting. But let's go on to the next level where we actually have a component function. So if we open this up, you'll see we're a little bit more complex. So instead of having a common HTML element in our render associated with our root, we're going to actually reference an element tag that doesn't exist within JavaScript. So I'm calling this one hello. And when Babel sees that, it's going to be like, oh, I don't know what that is. So I need to look for somewhere in the JavaScript code that I'm compiling a function which is called hello. So that's just right above here. I've got a constant function defined using the arrow syntax that says it's being assigned to the variable hello. And you want to make sure that case is the same on it. And it doesn't take any parameters. And it's just going to output or return the JSX, which is that right there, which is basically the same thing. I've just introduced a little bit of indirection here from the simple representation we had a moment ago to calling a function which returns that same simple representation. And we can play the same games we had before. So now within that function scope, I can actually have a constant, which is, name, and I can set that equal to, walk, and put that in there. And we can say instead of hello world, we can delete that and put in name. And now that should replace hello world with hello walk. As you saw that represented there. You can make that a little bit bigger so that you can see that happening. And that's the very simplest kind of representation of a component that you can have within React. You just create a function. That function is going to take parameters, which I'll show you here in a minute. Right now it doesn't take any. And then that thing's going to, as its return value, return the JSX that you want rendered in the place of that. And Babel's going to handle that rendering of that JSX and then the injection of that JavaScript function that represents that JSX into there. And that resulting HTML from that function will then get injected into the DOM using this query selector to put it into the child of that element that we selected there. So that's how it works. So we can make this a little bit more complex by actually, instead of hard coding this name in here, we could actually have a separate component. So we can have a name component. So we can actually do a function. We can set this to a value of name, and not using the arrow syntax in this case, which is fine. And then I'm going to just return, in this case, I'm going to return a span with the name walk in here. And instead of having this hard-coded here, I'm going to actually just reference my React component, my JSX component, by just specifying the name of that function and blowing there. And if everything works right, we should see that once again show up. Now, if I don't want to hard code the name in here, I can actually create a property, and I can put a value in here and say that that's just n. And instead of displaying that, I can display n. And then up in here, I can actually put an attribute and put that on there of walk right in there. And you can see as it refreshes. So you can take the attributes that you're passing to your JSX components in there, and you can receive them as properties there and then actually display them in there. So I took that a little bit further than a simple example, but I'm showing you, nested components with there and then passing properties between them to actually make them all fall through. And I can play the same game here. I can put message is equal to, goodbye instead of hello. And then up in here, I can receive that parameter of message and plop that right in here. So I can actually put message. Boop. And now it should say goodbye walk. Yep, there you go, except I misspelled goodbye. So we got to go fix that, and that's just embarrassing. And we're all good. Okay, so that's our next level of kind of complexity with things. So let's leave that so that we don't get saved there. And we'll come back to our class component, which is our last one. Now I'm showing you class components here, which is the older syntax of how JSX used to represent components. They don't actually use it anymore. They're deprecating it, and so it's not one that you want to learn. But I just want to quickly show you what it looks like so that when you see older JSX code, you know what this actually is. So a class component is similar to a function component, but you actually use the class syntax and you extend the React component class. And then instead of returning it, the JSX as a value, you call a render. You provide a render function that the JSX renderer will actually call every time it needs to display your component, and you pass back the JSX that you want there. So the main differences are that you're extending a class, the React component class, and that you're supplying a render function instead of returning the value from your actual function. And I'm just showing you that there, once again, so that you'll be familiar with it if you see it, but this isn't really a syntax that you want to use moving forward. You want to use the function style components that React is really pushing right now. So those are examples of simple components. So here's properties as I already demonstrated to you. Let's quickly review this again. So I've got my render function. I'm going to render this JSX, and I'm going to pass a property called phrase, which is function, and I'm going to inject the resulting JavaScript from transpiling that JSX into this element right here, selected based upon the ID root. So that function, I'm just looking for a function that has that tag name, and I find it up here. You can see this is where my property is being brought in, so that's my definition of the property actually existing. And I'm returning from this JSX, which injects or uses that property as part of the data within that. And once again, this curly braces here just means that I'm doing a JavaScript in rendering. So Babel's going to look at that, see the curly brace, and says, okay, I'm going to execute everything within here as if it was JavaScript. The curly braces up here is just using the object destructuring. So there's actually a prop object that gets passed in here as the actual parameter to it, and then I'm pulling out the properties of that object by using the object destructuring for actually using the phrases that was passed as an attribute here. So that's the difference. Don't confuse the object destructuring or destructuring with the JavaScript injection that's happening within the JSX there. So that's properties. The other thing that you can do that kind of defines the reactivity of a JSX object is specifying state. So the whole idea of React and why it's called React is to make it reactive to changes in either the properties or the state of a component. And it needs to kind of be aware of what those properties and state are so that it can know when to re-render the components based upon changes that happen within the application. Properties are easy for it to detect because it's actually calling those functions, right? And Babel's outputting a call within React that it calls in to actually create the rendering of it. So it knows whenever properties change. What it doesn't know is when state within your React function component actually changes. So in order to inject itself in there and know when those are happening, they use what's called a use state hook. And you define these within your function to say that I have a state within this component of hello, which is a color that is initially defined to be red. And if I want to update that color, then I'm going to call the setColor method to actually change what it is. I'm not going to change it directly by manipulating color. I'm only reading from that. If I want to update it, I have to call setColor. And the reason for that is so that React can know when the state of that class variable actually changes. You call that function, it knows, and then it figures out, okay, now know who I have to change in order to be impacted by that color change. So this example right here is declaring a state variable called color. This is the method that you use to update that color, and you get those two methods, or the value of color and the method to update the color by calling React useState, and you can pass in a default value. In this case, we're setting it to red to begin with. And then we can change our color whenever we want by just calling the setColor method. In this case, I define a function within this function, so it's an inner function that will call setColor, and it'll just toggle back and forth between red and green based upon what it was before. So just like our simple example, returning JSX here from our component. So this is a div. We're using the style tag, which remember this is JavaScript in here, and the JSX transpiler is going to know that, okay, everything that I define within this object is the properties that I'm going to assign to that style for this element. And here I'm just using the value of the variable color to set the actual text color of the element based upon whatever it currently is. And then if I want to change the color, so I implement a button that you click on, and it's going to call the change color function, which is going to go up here and just toggle back and forth between green and red. So you can kind of see the flow of how things are happening. The user pushes this. the color change function is called. It calls the set color method on the state variable, but it doesn't automatically like change it right as soon as you set that color. All that's doing is telling React that it needs to update that state color. So then it goes and computes all the dependencies that are based upon that variable, the color variable, which in this case, it knows that it's used as a property to this paragraph. And it's going to say, okay, I need to go re-render in the DOM that paragraph to display a new color because I'm toggling it. And when it's ready to do that, it goes ahead and re-renders it. And then the value of color will actually change when it's doing that rendering to the new value. And that's kind of the full round circle of the reactivity that React provides in order to make your state and your property variables visible within the DOM structure. The rest of this is just to actually, render with that property value and off running. So let's go ahead and watch this actually happen. If we go over to our code pin, you can see I've got the text right here, which is what we're rendering on. If I go push this button, it's going to change between green and red. And if I want to change this so that it's, instead of color, I want to make it background. Now remember, this is actual JavaScript, and so I can't use the CSS properties directly, but you just go to camel case, background, color. There you go. Now we're good. Now we can see the red. I'm going to go ahead and push the change button, and you can see that it's actually changing that value right there, back and forth. So I click on change, it calls this function, it sets the color. That doesn't immediately set the color, it just registers with React that it needs to analyze the DOM, figure out what's dependent upon that state variable, and then actually change it. And that's the kind of whole flow there. So that's our simple example of a React component and changing our state and properties. We can leave that and come here. And your assignment is then to go out to this React component and play around with it. So you've got code here, which has it's returning an element or a component called app. So if we look up our chain here, you can see here's our app function, and that app function has a child, which is a demo component who takes a parameter of who and what the function is. And that child component is receiving that parameter here, and then it sets an outlook state variable, and then it manipulates that based upon when the button is being clicked, changing it back and forth between exciting and beautiful. So I can click that, toggle that all day long. And we're going to, then that's wrapping up on everything that you need. And that's your very brief introduction to React. The key here is you need to go and play with it, experiment with it, get comfortable with it. We're going to next go into using React within your actual application, so actually building a web application using React. But you want to play around in CodePen so that you can make sure you understand how JSX works and understand the relationship between components, child components, the properties that are passed into them, and then also the state variables using the state hook of use state within the React library.